Okay, Michael, so I've erased the screen and kept Bellman's equation, the most important equation ever, and we are going to solve it.
Ooh.
So how are we going to make that work? Okay, so how many, so we wrote this down as a utility of S. How many S's are there?
S, N, M, I don't know.
Pick a letter.
N.
N. So we have N states, which means this isn't really one equation. This is how many equations?
N.
Yes, it's N equations. How many unknowns are there?
Well, we have a U. The R's are known. The T's are known. The only thing that's missing is the U's, and there's N of those as well.
Right, so there's N equations, N unknowns.
So we're done.
Yes, because we know how to solve N equations and N unknowns, right?
If the equations were linear,
If the equations are linear. Are these equations linear?
I'm going to go with no,
Why not?
because the max is problematic.
That's right. This max operation makes it nonlinear. So it looks really good for a moment there. We've got N equations, N unknowns. We know how to solve that. But max makes for a very, very, very weird nonlinearity. And there's kind of no nice way to deal with this. Actually, one day, Michael, if you ask me, there is a cute little aside you can do where you can turn max into something that's differentiable.
Ooh.
But that doesn't actually help us here. So I'm not going to go off on that aside yet.
But even differentiable wouldn't quite be linear.
That's right, and it wouldn't help us in this case. That's exactly right. But the fact that you can have differentiable max is, I think, actually rather cute, but also unimportant for what we're talking about now. So we've got N equations and N unknowns. They're nonlinear, which means we can't solve it the way we want to by like inverting matrices or anything like you people who are into regression would normally do. But it turns out that we can, in fact, do something fairly similar, something that actually allows us to solve this, even though it's nonlinear. And here's the equation, here's the algorithm that you use that sort of works, okay? So it's really simple. Just simply start with some arbitrary utilities.
Declare those the answer, and you're done.
That would be one way of doing it, but it turns out we can do even better.
Wait, start off with the correct utilities.
That would work, except we don't know what they are.
Oh, right.
So we're going to start with some arbitrary utilities, but then we're going to update them based on their neighbors. And then we will simply lather, rinse, repeat.
All right, so what does that mean based on neighbors?
So it means based on the states, you're going to update the utility for a state based on all of the states that it can reach. So let me write down an equation that tells you how to update them, and then maybe it'll be clear. Okay.
Yep.
So we're going to have a bunch of utilities. Since we're going to be looping through this, and let's just say every time we loop through, that's time t. Okay. So we know what the equation for a utility is. For the utilities are, it's just the equation that's written up here. So it's R of S plus gamma times the max over A of the expected utility, right? Except we have some estimate of the utility at time t, okay? And probably the right thing for me to do would be to write this like as U hat or something like that. This is my estimate of the utility. And so now using this, I'm going to want to sort of update the, all of my utilities and make them better. And it turns out I can do that by simply doing this. So I'm going to update at every iteration, update utilities based on neighbors. I'm going to update at every iteration my estimate of the utility of some state S by simply recalculating it to be the actual reward that I get for entering state S plus the discounted utility that I expect given the original estimates of my utility. Does that make any sense at all?
Yeah, I guess so. So the S, okay, so we need the whole U hat T, like at all states, because we're not just using the values at state S to update the values at state S. We're using all the values at the previous time step to update all the values at the current time step.
Yep.
So all these N equations are all tangled together.
Right, because of this expectation. So really, just to make it clear, this should be a summation over S prime.